Hello. Good morning, everybody. Good morning, sir. I'm really very thankful to the principal of this college, professors, and organizers of this Transtech 20 to give me this opportunity to stand in front of you with little bit of experience and knowledge that I have gathered in the area of engine and transmission design and development. It was a new experience for me to get into this campus where I could see a good lakeside view and a part of the ship which I had an opportunity to step up and see around how an engine room looked like. And I found the engines that I am dealing in my life, the size of that engine can go into the bore of the whole engine that you are using in the ship probably. I'm coming from Automotive Research Institute. In short, it is known as ARAI. And probably many people know about ARAI as a certification and homologation institute or test agency in India, looking after doing the type approval, homologation of engines, vehicles, subsystems, systems and aggregates before they are allowed to get launched commercially on the road. And before that they should get through the type approval activities. And ARAI does more than 3/4 of that business in India. This is one side of ARAI. Another side of ARAI which is not much known to the public, and we are reason for that is the development work. I come from the research background. I am head of powertrain engineering, looking after design and development of engines and transmissions for various applications, specifically dealing at this moment with the land transportation. Not got much opportunity to deal with the marine applications as such, but we have just started embarking in that region as well. Because engine is an engine, philosophy of the design, working principles, they are going to be always same when it is an engine used by a piston crankshaft mechanism through the connecting rod. Yes, boundary conditions, load patterns, and some of the features may differ from application to application, but the basics will remain same. And working in the area of engines and transmission, I'm very happy to share with you that it's my fortune that I've been able to utilize some of the knowledge of various disciplines of engineering that is required, because we deal with different fluids, oil, water, fuel, then many things, right from thermodynamics to combustion to theory of machines, strength of materials, fluid mechanics. You name the topic of engineering and it is required to be done. It's required to be used when designing the engines. My work involves right from concept development of the engine to do the thermodynamic simulation, combustion simulation, doing all kinds of design calculations of every system and part and components, layouting, doing the complete packaging, weight measures, noise, vibration, materials, everything from production point of view, because we have to do the design of engines from the manufacturing point of view. It should be packageable, it should meet the targets of weight, noise, performance, emissions, specific power, specific torque, fuel consumption, oil consumption, durability, reliability, everything and everything. Then only it will be useful finally in the field. And while doing that, me and my team were fortunate to deal with the engines, designing from as small as 100cc engine of 5 horsepower for a two-wheeler application to the biggest engine that I have dealt in my so far small career is about 1,500 horsepower engine developed for military application. Not more than that I got the opportunity, but this is the range of applications of engines we design, and right from concept development on the piece of paper, then making the prototype engine through all the processes, then proving the performance on the engine dynamometers or in the vehicle after it is fitted with the integration, and then finally handing over the design to the OEMs. This is whole activity we perform in ARAI in powertrain engineering department. And then finally we have to also prove the durability, because design is only acceptable when it works in its life. So we have to also ensure that it is durable, it is reliable, and if there are any problems, because design is always with some gray remarks, we have to do some design corrections if it found it is found something not working to the mark, and we correct the design, and finally, then only it is launched commercially. We have been working for Indian OEMs, and I have got several opportunities to work for some overseas OEMs also in designing. Same thing I do for transmission, so that's why it's powertrain from engine to wheels. And while dealing with that, fuel to flywheel, I call it, that the energy of the fuel ultimately I get in some form at the flywheel, and once it is available in the rotational form at the flywheel, how do you utilize for different applications? It is all giving to us. It can be two-wheeler, it can be four-wheeler, it can be heavy goods transportation, it can be generator engine, it can be off-road engine, it can be any engine. That's why as an internal combustion engine design person, I don't have any boundaries, whether I work it on land or water or in air. So long as it is an engine, I can always involve myself in the design. Yes, boundary condition, loading pattern will change. So with this background of little experience with me, I had chosen the topic, though it is not directly related to probably of your interest in maritime engineering, the general topic, that in the changing scenario, we have got several opportunities available in front of us to meet the future mobility as far as the land mobility is concerned, or mobility for a general public, and what type of technologies are available, what kind of solutions are there in front of us, what to pick right for us, what is the right mix of the mobility transportation in coming future to meet various perceptions and expectations of a common man. So this is the topic I have chosen. What is in the plate for future mobility solutions, and in what way we can find out what is the right powertrain mix, because we will be always having n number of options in front of us, and as a human being, when there is more than one option in front of us, there is always a dilemma, what is right. And when there is a dilemma of what is right, we all get into trouble, because then it requires a brainstorm. Because unless we do brainstorm, we will not be able to find out what is the right. Because from surface you can see something good or bad, but when you go more and more deep into it, you will find your answer, your reply, or your final solution may be completely different what you have thought when you were on the surface. So this is how a common engineering practice is done. Dr. Thakur has very rightly said clever, smart, all these definitions to all engineers, and this is really coming into when it goes to finding out the engineering solution for everything. I always understand myself, we always take pride to say that we do optimization during engineering. This is just to give a good label to it. Actually, we do not do optimization, we do compromisation. Actually, we do compromisation because we are not able to satisfy everything what is required from engineering principles and all that. Then we try to find out how best we can get so that somebody is satisfied, something is not satisfied, but what is the best out of it? So we are doing compromisation, but to give a good name to it, because we are human beings, always try to get good out of everything. So we do compromisation, but we give a good name to optimization. And with this background, whenever I work with my team in my department, we always say, learn to compromise, then give a good name to it, optimization. So with this, transportation, which is the lifeline for all of us. We all want to go from one place to other place, from somewhere to somewhere, anywhere to somewhere. Therefore, transportation has become a very, very inevitable part of our life. And therefore, moving the people, moving the goods, moving anything from one location to other location has become very, very primary requirement of the society and primary requirement of the human being who is a part of the society. I always say there are three aims. When I say aims, mean AIM, aims of a common man. One aim is that he wants to get mobilized from one location to other location. Without mobility, he will be completely dead, DAD. He will be DAD, dead. And second thing is mobile. Today, everybody wants in his hand mobile, except I think during taking bath and when he wants to go to take sleep in the bed. Only these two occasions when mobile is not probably in his hand. Otherwise, throughout the 24-hour time, mobile is always in the hand. And without mobile, we are going to be mad now. If we don't get signal even for a second, we feel that we are completely disconnected and something is going to fall on us. So mobility and mobile. These are the two major requirements of the human being. And the third M, which I'm just perceiving, the man would like to rehabilitate one day on some other planet like Moon, because that is what is happening nowadays, Moon or Mars or whatever the case is. So mobility, mobile and moon living, these are the three aims of the modern society, and with this we are all working in that direction. And when it comes to the topic of the day is the mobility. It can be land mobility, it can be air mobility, it can be water mobility. And when it's land mobility, most of the people are more closely connected to it. And whenever we are on the land mobility, what we are doing? We take fuel, it has to do some combustion with the oxygen available in the air, which produces force or some sort of work, which is then used in different applications. And while doing that, whenever there is a combustion taking place, many products of combustion do come out in the tailpipe, and some of those combustion products are undesirable for the common public, for the ecology, or for everything from the health point of view, for ecology point of view. And because they are undesired, they are called pollutants. And when they are pollutants, everybody is trying to control them, reduce them, if possible, eliminate them. And while doing that, there are many aspects which have been regulated now. Because when we have to do a design and perform, unless there are regulatory requirements in front of us, we do not understand where to stop and what to achieve. All our designs are regulation-based designs or regulation-driven designs. So we have to control emissions, we have to achieve safety, because safety is first. This week is a safety week, I believe that this is a safety week. Then CO2 emissions. Once upon a time, whenever fuel used to get combusted with the air and we have to complete the chemical reaction, we used to say if it produces with full chemical reaction only CO2 and water vapor, it is the best chemical reaction, because then nothing else is there. That means if CO2 is produced and only water vapor H2O is there, this is the best chemical reaction, and the complete energy of the fuel is converted with the best efficiency. Lately, that CO2 has been considered as one of the undesired components because of its connection to the global warming. Therefore, now the interest is going to reduce CO2 emission. And CO2 emission reduction means reducing the fuel quantity conversion. So if you reduce the fuel consumption or quantity of fuel consumption, CO2 can be reduced. That means, in other words, we have to improve the fuel economy. If you improve the fuel economy, for the same work, fuel consumption will be less. If you consume less fuel, less hydrocarbon, less CO2 will be formed. As an engineer, I always say that we solve a problem, create a new problem, and then again get engaged in solving that problem. This is how there is a continuity in our business. Giving due respect to the doctors or that profession, people normally say jokingly, doctors are not like that. So whenever we go to the doctor and ask for a medicine for some illness, probably he will not completely cure and will leave something in your body so that you go again and he gets further business. Similarly, engineers, we try to solve a problem and create new problem and then get our continuity of the business. I'll give an example. As an engine person, we worked hard for several years to reduce the particulate matter, PM, because that was one of the carcinogenic component coming out of the engine tailpipe, giving a lot of issues concerning cancer type of things. But while doing that, we refined the particulate matter to such a lower extent that now the particle size coming out of it is less than 10 nanometers or something like that, 2 nanometers, 2.5 nanometers, much lower than that. And it is so easy to inhale those particles now that is giving us trouble, because we are able to easily inhale those particles, and then it is going into the hemoglobin and giving further problems to the health. Now we are all working how to now control those particle numbers. Therefore, now from BS6 onwards, that is from 1st April 2020, the regulation has come not only to control particle mass PM, but also to control particle number. So that maybe after 4 or few years or 5 years, the new regulation will be expected to control particle size also. So there will be particle mass, which we have been controlling for last 10 years. Now from this 1st April 2020, it will be particle number, and then it will be particle size, so that the smallest size that cannot be inhaled by our nasal system can be at least develop in the engine tailpipe, and we can save our life. This is how the work goes on. Then of course, whatever we use as the equipment or component, everything has got a life. But after that life is met, how to deal with that, how to dispose it, so that it will not become another problem on the earth. But disposal policies, end of life policies are very important. And the material that we use should be ecologically acceptable, recyclable material. These are all the regulatory aspects during the design process. Now all engineering professionals will have to be dealing with, whether it is for two-wheeler or it is for maritime or it is for the airplane application. But what is more important is the end user, customer, we. We have to give very good fuel economy to the customer, we have to give very good performance to the customer. It is torque, power, it can be fuel consumption, it can be safety, comfort, it can be range. So that is very important. Once you fill the tank, how many kilometers you can travel is of great interest. That's why there is a big fight going on between electrified transportation and conventional combustion transportation. Durability, of course, reliability, cost of purchasing the component, and maintenance and servicing cost. Based on all these aspects of regulations and the customer's perception, one is to design the component, and then only it will stand very hard in the market. Therefore, the focus areas for all of us, irrespective of the application, is the fuel economy, emissions, because we are all concerned about it, energy security, because in India, more than 80% of our fuel demand is met by importing the fuel. We do not have our own crude stock. Therefore, in the present scenario of cost and many political and war-type situation, we have to find our own ways of doing it. Either we have to completely go out of using the fuel, crude petroleum, or reduce the fuel consumption, or find some alternatives. So for energy security, and of course global warming, because we are all concerned about it. So these are some of the focus areas for the transport sector. I am not saying it is for transport sector, even for the industrial application. Wherever fuel is involved, wherever internal combustion engine is involved, all these things are equally concerned about. And when we talk about various drivers around us, there are typically primary drivers and secondary drivers. In primary drivers, we can say economical drivers, social drivers, environmental drivers, and to support them, we have to look into the political policies, we have to look into the technologies available, and we have to also ensure that everything that we design finally is well supported by the infrastructure. A very good vehicle on the road, but if the roads are not good, there are potholes, there are very badly designed speed breakers, there are no bridges, there are no proper lanes, there are no aligned traffic signals, then what that good fuel economy will get from that nicely designed vehicle. Therefore, unless the powertrain design advancement is properly supported by the infrastructure development, we will not achieve final goal of fuel economy, final goal of energy security, final goal of air quality control. So these are all depending on each other. So typically, in Indian scenario, as we all know, more than 75% of our population is two-wheeler, 3/4, and then remaining are the things. And two-wheeler typically, as on date, uses mostly the gasoline